In the first part, we have discussed that like charges repel each other and unlike charges attract each other. Now the question is, how strong are these forces? I mean, what is their strength? Are they stronger than gravitational forces or weaker? When we look at day-to-day situations like objects falling on Earth due to gravity and Earth revolving around Sun and Moon revolving around Earth, in all these situations we calculate only gravitational force but not electrostatic force. So you may think that gravitational forces are stronger than electrostatic forces. But in case of atoms, in atomic structure, we discussed that electrons are able to revolve around nucleus due to electrostatic force, not gravitational force. So there we consider electrostatic force but not gravitational force. Why? So let us compare strength of gravitational force and electrostatic force once we discuss Coulombs law. So let us discuss Coulombs law. Coulomb has done a lot of experiments and he has given the first successful theory on electrostatic force. So now let us consider two point charges, Q1 and Q2. Let the separation between them be R. Now this is force on 1 due to 2 and this is force on 2 due to 1. So these two are action and reaction, so their magnitude will be equal. So let the magnitude be Fe. So now in his experiments he observed that Fe is directly proportional to product of charges, and he also found that it is inversely proportional to square of the distance between them. So now when you club these two expressions, you will get Fe is directly proportional to Q1 Q2 by R square. Now the removing proportionality constant, we get Fe is equals to K, some constant, into Q1 Q2 by R square. So this is expression for electrostatic force between 2 point charges separated by distance R. So where K is Coulomb's constant or electrostatic constant. So K is electrostatic constant or Coulomb's constant. Its value is 9 into 10 power 9. Now let us compare this expression with universal law of gravitation. There we got expression for gravitational force between 2 point masses as G into M1 M2 by R square, where G is universal gravitational constant and its value is found to be 6.67 into 10 power minus 11. So here you can compare the two constants. So K is 9 into 10 power 9 and whereas G is 10 power minus 11. So K is far greater than G. So when you take unit charges at unit distance, you will get the force to be 9 into 10 power 9, and similarly you take unit mass M1 1 kg, M2 1 kg and R as 1, then you will get force as G, that is 6.67 into 10 power minus 11, so which is far less than K. So here we can understand that electrostatic forces are far stronger than gravitational forces. But why we come across only gravitational forces in case of larger bodies? It's because these larger bodies are neutral, they are uncharged. The net charge on these bodies is 0. Due to that, electrostatic forces on them will be 0. So we consider only gravitational forces. So we discussed the expression for magnitude of electrostatic force. But force is a vector quantity, so magnitude alone does not define the force, so we need direction. So let us discuss vector form of Coulombs law. So the electrostatic force between the charges is always along the line joining the charges, and for like charges it is repulsive and for unlike charges it will be attractive. So now let us write expression for force in vector form. So let us consider the position vector of 2 with respect to 1 as this R21 bar. Now the direction of this force 21 is along this position vector. Now F21 bar will be magnitude of it, we already discussed by Coulombs law, and the direction is R21 cap. So now force 21 bar, that is force on 2 due to 1, will be K into Q1 Q2 by R square into R21 cap. Now we know unit vector is equal to vector by magnitude of a vector. So F21 bar is equals to K into Q1 Q2 by R square into this unit vector. We can write it as R21 bar by magnitude of it is R. So finally we will get R21 bar as K into Q1 Q2 by R cube into R21 bar. So this is vector form of Coulombs law. Similarly, we'll get an expression for F21 bar, that is force on 1 due to 2, as K into Q1 Q2 by R cube into R12 bar. So this is how to write force in vector form. From Coulombs law, we got the expression for magnitude of electrostatic force between two point charges separated by distance r as K into Q1 Q2 by R square, where K is Coulomb's constant or electrostatic constant, and it is given by 1 by 4 pi epsilon naught, whose value is 9 into 10 power 9. Here epsilon naught is permittivity of free space. Now the force applied by one charge on other charge does not depend on the medium present between these two particles, but due to polarization of medium particles, the net force acting on each charge will change. So let us discuss how this force depends on the medium. So we have already discussed, when a charged particle is brought closer to an atom, due to attractions from this positive charge, the orbit of electron gets distorted, and due to this the dipole formation takes place. So now let us consider these two particles in a medium. Now you have several medium particles. Let us consider one medium particle. Initially the electron is revolving around the proton in circular orbit. Now due to attractions from this charge, this positive charge, this atom gets distorted and the shape of this atom changes like this. Now the concentration of electron will be shifted towards the charge. Due to this, the negative charge will be closer to the atom and the positive charge will be far away from the atom. So now due to this dipole formation, there will be a net force acting on this towards the atom. Now similar to this atom, there are several atoms in this medium. So due to these distortions, there will be a force applied by the medium on these two charged particles. So due to this, the net force acting on these two charged particles will change. The net electrostatic force is given by K into, or 1 by 4 pi epsilon into Q1 Q2 by R square, where epsilon is permittivity of medium. Basically, permittivity gives you an idea about how strongly the medium particles are get influenced by external charges. So due to polarization of medium particles, the net electrostatic force acting on the charged particles will change, and this net force is given by 1 by 4 pi epsilon into Q1 Q2 by R square, where epsilon is permittivity of the medium. So now when you compare the permittivity of medium and permittivity of free space, permittivity of medium by permittivity of free space is termed as relative permittivity of the medium. So here epsilon r is termed as a relative permittivity. Now if we consider the free body diagram of this first particle, there are two forces acting on it, that is force applied by second particle on the first particle and force applied by medium on the first particle. Now if we write net force acting on it, F net is equals to F12 bar, that is force applied on 1 by 2 plus Fm bar. So from here you will get force applied by medium on the charge is given by F12 or F net bar minus F12 bar. So this is expression for force applied by medium on the charged particle. Similar to all forces, electrostatic force also obeys principle of superposition. According to this principle, when there are more than two charges in a system, then the net electrostatic force on any charge is given by vector sum of all the individual forces by independent charges of the system. So what we mean by this? Let us understand by taking an example. Let us take three charges in a system. So let us say Q1, Q2 and Q3. Now these two charges will interact, so they will apply electrostatic force. So let us say, so this is force on 1 due to 2 and this is a force on 2 due to 1. Next, these two charges interact, so this is a force on 1 due to 3 and this is a force on 3 due to 1. Similarly, these two charges will interact, so this is a force on 2 due to 3 and this is a force on 3 due to 2. So these are the forces. Now if you want to find the net force acting on, say, first particle, it is equal to vector sum of these two forces. So F1 net, that is net force, net electrostatic force on first particle, is given by vector sum of these two forces, individual forces. So these are the two individual forces by independent charges. So this is what principle of superposition says. So guys, let us discuss few applications on Coulombs law. So the first one, three identical charges Q0 each are placed on the vertices of an equilateral triangle. Then find net electrostatic force on the charge placed at A. So guys, pause the video and try the question, and then you can look at the solution. So charge at A and charge at B interact. As these two are like charges, the force will be repulsive, and this is force on A due to C, and similarly these two charges interact, so force on A due to B, and this will be force on B due to A, and this is force on C due to A. Action reaction. Now we want net force on this one, so let us take free body diagram of charge A, charge at A. So this is one force, that is force at on B. Next, here in this direction, force on A due to C. Now we know this is an equilateral triangle. The angle between the sides is 60, so all the angles are 60 degrees. So now this is 60 degrees, so opposite angle will be 60. So the angle between these two forces is 60. Now, so we know this value is equals to, we know Coulombs law, according to Coulombs law, force of repulsion between two like charges is K into Q1 Q2 by R square. So let us write this one. So we'll get this value as K into Q0 square by A square. The distance between these two is A. Here also A, here also A. So this, let this be some F0. Similarly here, force on A due to B, K into Q1 Q2 is Q0 and Q0, so it is Q0 square by A square. So this is also F0, let us say. So we have an expression for net force as F net is equals to under root of F1 square plus F2 square plus 2F1 F2 cos theta, where theta is angle between the forces. So this is the expression for net force. So let us substitute in it. F net is equals to under root of F1 is F0, so F0 square plus F0 square plus 2F0 into F0, 2F0 square into cos 60. So cos 60 is 1 by 2. So we can substitute here. So we'll get F net is equals to under root F naught square plus F naught square plus cos 60 is 1 by 2. So here 1 by 2 and 2 gets cancelled. So we'll get 3 F naught square. So from here you will get F net is equals to root 3 into F naught, where F naught is K into Q square by Q naught square by A square. So this is how to find net force acting on the charge at point A. So the next problem, guys, 4 identical charges Q naught each are placed at 4 vertices of a square of side A. Then find net force, that is net electrostatic force on the charge placed at point D. So pause the video and try to do the question. Now let us discuss the solution. So the force acting on D due to B will be in this direction and it will be repulsive as it is like charges. Similarly, force due to C on D is in this direction and it is also repulsive, and the force due to A on it will be D, or A on D will be in this direction. So this is force on D due to A, so this is force on D due to B, and this is force on D due to C. So now let us calculate these forces. So force on D due to C, so K into Q1 Q2, Q0 and Q0, so it will be Q0 square by the distance between these two charges is side A, so A square, let it be F naught. Next, so force on D due to B, force on D due to B is K into Q1 is Q0, Q2 is Q0, so Q0 square by distance between these two charges is again side A, so A square, so this is also F naught. Now let us calculate force on D due to A. Force on D due to A, it will be K into Q1 Q0, so Q1 is Q0 and Q2 is also Q0, so Q0 square by the distance between these two charges is diagonal, so diagonal will be root 2A, so root 2A whole square, so it will be K into Q0 square by 2A square, so this is F naught by 2. Now there are 3 forces, so we have to calculate vector sum of these 3 forces. So now there are 2 ways in which we can do this problem. First method is you can take resultant of these 2 forces. Resultant of these 2 forces will be in this direction. Then we can add these 2 forces, the resultant force of these 2 as well as this third force directly as they are in the same direction. So first method, so F naught and this is F naught by 2. So now F naught and F naught, angle between these 2 vectors is 90. So let us calculate F net due to first 2 forces will be under root of F square, F naught square plus F naught square plus 2 F naught into F naught, angle cos 90, cos 90 will be 0, so this is 0, so we'll have root 2F. So due to these 2 forces the net force is root 2F naught. Now the net force will be equal to sum of F naught by 2, that is force on D due to A, plus resultant of force on D due to C and force on D due to B. So it will be root 2, so we can write it here, so F plus force on D due to A, so this will be F naught by 2 or root 2 F naught plus F naught by 2. So this is the force, so you can substitute F naught. So this is how to calculate force on D due to 3 charges in first method. Now let us do by second method. Here what I'll do is I'll take components of this force along horizontal direction and vertical direction. So before explaining you this, I'll tell you how to take components. Let us say you have a force F and you want component in this direction. First we have to find the angle between the original force and the direction in which you have to take the component. If this angle, let this angle be theta, so now component in this direction is given by original force into cos of angle between these two forces, so theta, so it will be F cos theta. So that is how to calculate the component. So now let us calculate components of this one along horizontal direction and a vertical direction. So F naught by 2 is original force and this angle, so we know in a square the angles, this diagonal will make an angle 45 degrees. Here also it will be 45 degrees, so this angle will be 45 and this angle is also 45 degrees. Now component of this one in this direction, F naught by 2, similar way, F into cos theta. So here F is F naught by 2 into cos 45. Similarly here in this direction, F naught by 2, F naught by 2 into cos 45. So these are the two components. So now these two forces are in same direction, so we can add them directly. So the net force in horizontal direction will be F naught plus F naught by 2 into cos 45 1 by root 2. So it will be F naught by 2 root 2. Similarly in vertically downward direction you have F naught plus F naught by 2 into cos 45, so it will be F naught plus F naught by 2 root 2. So now this is one force and this is another force, both are making an angle 90 degrees. So when two identical forces are making 90 degrees with each other, then the resultant is given by, so if you have F and F, the resultant will be root 2F. So because we know F net is equal to under root of F1 square plus F2 square plus 2F1 F2 cos theta. From that formula you will get the net force as root 2F. So now here we will get F net as root 2 into F naught plus F naught by 2 root 2. So this is how to solve the question using components method. Guys, the next part will be completely based on the applications of Coulombs law. In that video, I'll completely concentrate on how to build an approach to objective questions from the very basic level. Guys, if you find this video helpful, please hit the like button. In this series, I'll cover entire JEE syllabus. And apart from physics lectures, we will be coming up with exciting videos on career guidance, like review videos on engineering colleges and detailed analysis of all branches. And we are also planning to share informative videos on entrepreneurship. So if you don't want to miss out on these videos, please subscribe to our YouTube channel.